Today, hi everyone. So for this cluster of videos, I will be discussing lifting value, direction weights, and pointers. So let's get started with the outline. So the first thing that we should identify or is what we discuss is the heating value of solid fluids. So we want to determine first what are the usual devices to measure the value of it. Then after that, we'll also discuss the empirical formula of solid fuels and liquid fuels. Today, heating value will also discuss how chimneys and boilers are designed or treated. Okay. So today, to start with, we have the heating value in general. So we've discussed this before that the heating value is just the amount of energy extracted from the combustion chamber. So we have two types of heating value. We have the higher heating value and the lower heating value. So the difference between the two is that in the higher heating value, we are considering both the energy extracted from the combustion chamber, including the energy that is transferred to the water vapor, no, to the combustion. So the difference is basically just type this term here. Type this one. Type this one right here. So if you can condense the products, this water vapor products. So meaning you can extract the energy from this water vapor, then you will have the higher heating value. So most of the time, you can only extract the lower heating value in realistic scenarios. I will measure the heating value of fuels. We usually use this pump calorimeter for measuring the value of both solid and fuels. And how does this work? We have this chamber right here, this very chamber here in the middle, wherein we put our fuel. So in this types container right here, we put, let's say, some gasoline or maybe some coal. After that, we can ignite this fuel. Oh, so we have an igniter to ignite this fuel. And then, of course, we need some oxygen supply. So after it is ignited, and the heat will be transferred from this chamber right here into the water. The energy transfer here into the water. So what happens is the water temperature will rise. And the temperature rising in the water can be quantified change in internal energy. So therefore, the heating value can be measured. Also, let's say you put one kilogram of coal here, you can find the heat received by water or stored in water using the Q is equal to mCp. So how much water is in there, and then the Cp of water and the change in temperature. So after that, you can just divide this by how much coal put in the calorimeter. So that's it. Type. Okay. So most of the time we already have a way to find different types of to find heating value of a variety of compositions of solid fuels. Usually they're analyzing codes, diba? So we have Dulong's formula, which is an empirical formula for identifying what is the heating value of, or estimating the heating value of solid fuels. Now, we have this formula not for high heating value, which is 33830 plus 144 H minus over 8 plus 9420 S. And basically just the C, H, and O, and S here are the ultimate analysis of carbon, hydrogen, oxygen, and sulfur respectively. And as you notice, maybe you'll notice this, but the actual actual formula either textbooks or specific than the centers textbooks. They have it different than this. So I think this is 144212. They has 9304, I believe, and then just the 33820. But anyways, it will be okay either uses or the latter because this is just an estimation of the rate high reading value. So usually different textbooks has different values for these coefficients. Usually they are in calories or in BT per pound. Rate high at times it gets lost into the conversion and this testing parameters. So they are different in a lot of ways. But we can just use this formula or either this from the review center topic. Okay, Harry. So you can also find the low rating value when you remove the latent to vaporization energy from condensing this water vapor into liquid water. Okay, Harry. So you just have to deduct this to 442 minus the mass of the water. So the unit of this is in kilogram of water, no? So kilogram of H2O, rate type kilogram, rate type fuel. Okay. So in here we have an equation to represent this. Rate type to the H, no? So the H here can be also identified using this one. If it only has an SG, no? But if you have an ultimate analysis, it will be better. But if you don't have an ultimate analysis, again, rate types rate types used for liquid, no? Liquid fuels. But times is rate types. And this is also still an empirical formula. Rate type is these values or these coefficients are found. Rate type experimental data. Rate type the eating value of liquid fuels may be determined this in these two ways. We have the oxygen bomb calorimeter, or we just use the rate of formula that we have output classes. Okay, and then we have few last ones for liquid fuels. So we also have an empirical formula for finding the eating value of rate type fuels. So we have the actual formula, which is 41130 plus 139.6 TPI. 63 API is actually rate type is another measure. It's like a temperature, but it's not the temperature. And this usually found when you have the specific gravity of the fuel given. Rate type 160 degrees Celsius. Rate type even your specific gravity you can find the API, therefore you can find the high rating value. Rate type to two alternative methods can use that method. We also use the Bureau of Standards method. So for the Bureau of Standards, we have also this formula for finding higher rating value. So just to add to this, sometimes the specific gravity can change, right? So it is dependent upon temperature. So if you may realize that rate type heat oil, right? Rate type's a little rate type dense. Rate type if it has fuller, it gets a little dense. Although rate type realistically it's actually viscosity that makes rate type the fuel the you see for example oil a little solid rate type of solid particles. So rate type and then I'll just make this simple na as temperature increases the specific gravity increases rate type increases, therefore the density also decreases. Rate type one rate type idea is that if you should ask yourself when should you buy rate type in our diesel, no? Rate types that they should you buy instead of gasoline. Rate type we bought at colder colder hours, no? Rate types and behind that is that rate type colder temperatures it is much denser. Although it is negligible, but it might be something on the other hand that will be let's say for 1 year you will have an extra liter, for example. If you usually use this strategy. But anyways, it is negligible in a so it might be helpful in larger or larger volumes. Rate type we have a way to find the rate value of hydrocarbon, which are liquid. No? Actually, in this can still be applied in solid fuels that is hydrocarbon. Rate type, rate type, you can find this formula. Rate type, but this is actually in BT per pound. Don't BT per pound just to take this. Rate type, and basically, this is just the ultimate analysis. No? We've already discussed this in the first part of our lectures. Rate analysis. Rate type A, so that's it. Yes. Rate type, rate type, rate type, rate type, rate type.